Okay, so we're group five,
Start.
consisting of Minjae Kim, Tim Jun, Caleb Park, Sarah Oh, and Min Sung Kim, and we're analyzing deforestation for different continents. So in our order of contents, we're going to go over our definition of the problem, briefly highlight our data sets and methods used, go into our analysis, and then make our conclusions and then steps moving forward. All right, so the primary issue we're addressing is the constant decrease of forest area all around the world. So why even are forests important? So as you can, so forests play a critical role in maintaining biodiversity, as it's the home of countless organisms. They also regulate the climate by removing carbon dioxide in our atmospheres and replacing it with oxygen. And furthermore, the trees in the forest also protect our water quality by absorbing water and filtering out pollutants. So our main question is there a correlation between forest areas and CO2 emissions and or temperature change? So our hypothesis was that we expect an increase in temperature change to have a correlation with a decrease in forest area, as less forest area will increase temperatures. And we also expect an increase in CO2 emissions to correlate with the decrease in forest areas. To briefly highlight the data sets we use three main data sets containing countries' data on specific information relating to global warming. So on the left side, you can see rows split up by country and having data about temperature change over the years, like how much it changed, how much it increased or decreased. And then in the middle, it's a data set illustrating the annual carbon dioxide emissions per capita in all countries. And lastly, on the far right, portrays the percent of land that was forest area for each country. And when it comes to big data sets, it's imperative to fully clean out the data in order to get accurate data when answering our question. So first of all, our data sets had some missing data. So we decided to simply drop all the data that weren't available. And since we're investigating data by continents, we separated all the countries by continents. And methods used. So in order to analyze the question at hand, we use Jupyter for the code. And we also use Python libraries such as matplotlib, which allowed us to perform linear regressions and visualize the data as a whole, pandas to read the data and drop to null values, and also SciPy, getting the precise correlation coefficient for the regression graphs.
Okay, so moving on to our analysis, we performed the same analysis for all content to see differences. So this one is North America, and it showed a strong and negative correlation between CO2 emission and forest area. However, if you look at the right side of the graph, it shows a moderate positive correlation between temperature change and forest area. If you look at Europe, it's pretty similar to North America, just that it has a slightly less correlation between values. However, if we move on to Asia, Asia has a very strong positive correlation between CO2 emissions and forest area. While similar to North America and Europe, it has a strong positive correlation between temperature change and forest area. But if we move on to Africa, just like North America and Europe, it has a small negative correlation between CO2 emission and forest area. But it also has a strong negative correlation between temperature change and forest area. Similar to Africa, Central and South America had a negative correlation between CO2 emission and forest area. It also had a strong negative correlation between CO2 emission and forest area. Temperature change and forest area. Oceania was a bit different. Although it had a pretty strong negative correlation between CO2 emission and forest area, it showed more correlation between temperature change and forest area. So this is the graphs of forest area for all the continents over the years. So from the top left to bottom right, we have North America, Europe, and Asia, which are generally increasing forest area over the years. And we have Central and South America and Africa, which had the forest area decreasing over the years. But Oceania, their forest area was decreasing up to 2010, but it started to increase after that.
From our analysis with continents, we found out that 5 out of 6 continents had a negative correlation between the CO2 emissions and forest area, meaning that the higher the CO2 emissions were, the worse the deforestation was. However, 3 out of 6 continents had a positive correlation between temperature rise and forest area. 2 out of 6 had a negative correlation, while 1 had no correlation at all. From this result, we were able to conclude that an increase in CO2 emissions led to severe deforestation, while temperature does not appear to have a significant correlation with deforestation. However, we observed distinct trends in different continents. North America, Europe, and Asia experienced a continuous increase in forest area over the years, while Africa, Central and South America witnessed a continuous decrease. As a result, we formulated an alternative hypothesis based on the economic status of these regions. Notably, North America, Europe, and Asia are economically more prosperous compared to Africa and Central and South America. As a group, we speculated that the extent of forest areas may be correlated with the financial resources each country can allocate to forest service management. To validate this hypothesis, gathering data on the amount of money invested by each continent into forest area management could confirm our assumptions. Based on our analysis, implementing these measures could contribute to preventing deforestation. And these are the references for our data. Thank you for listening, and if anybody has any questions.
Yeah, quick question. Could you please re-explain why you use linear regression for the CO2 or like the correlation coefficient?
Okay, so we're talking about stuff like this correlation coefficient number here.
Yeah.
Okay, so we did this analysis and we found out that this correlation coefficient showed a strong negative correlation between CO2 emission and forest area. And because most of the continents showed this kind of trend, our conclusion was that CO2 emissions lead to decrease in forest area. Is that what you're asking for?
So
I think the question itself is, why the regression approach rather than interpreting the regression result, right?
And yeah, and also with your data, especially like North America, like your data is all over the place, and using linear regression on this, like do you have an do you have a accuracy score? Like how accurate are your results? Because your data is like everywhere. So your accuracy was that's your correlation coefficient?
Yeah. We showed in our here from Skype stats import Pearson R. This is the one we use for our correlation coefficient.
Right. So how accurate is your linear regression? That's what I'm asking.
Just as the number shows here.
No, so that is just correlation coefficient. Yes, just something like an R-square number.
Yeah, I'm looking for the R-squared score.
Yeah, so using R-square, then it's gonna say that how this correlation gonna explain the data. More fundamentally, so in this discussion, what is the exact meaning of this dot? The forest area. Then what is the meaning of this dot?
In a particular year, for example, if you look at this dot on the North America for CO2 emission and forest area, for a particular year,
so individual dot is a year?
Yes, from 1990 to 2020.
Oh, okay. So then, yeah, okay. Individual year and yeah, year has two values: forest area, maybe the total forest area, maybe. Am I right? And
it's
then
it's percentage of how much forest area is there for continents.
okay, so what about this? So it doesn't matter, right? Okay. And then CO2 emissions per capita. Okay. And my question is, why the x-axis is CO2 emissions per capita and y-axis in a forest area. Something like, which one we can control. So usually, which is independent in a variable and which is dependent variable. Yeah, actually, we cannot control in a CO2 emission, right?
Yeah.
That is a kind of result. But the forest area, yeah, we can plant some trees and then we can cut out some trees. So when you have, a forest area in the x-axis, then what do you think, the shape looks like? It's a little bit confusing, yeah. So this graph means what?
Like that increase in CO2 emissions could lead to decrease in forest area.
Yeah, so when you decrease the forest area, then CO2 emissions per capita gonna increase, right?
Mm-hmm.
And then when you increase the forest area and temperature also increase. What? So the forest area increase and the temperature also increase?
Yes, for North America, Europe, and Asia, it showed like that.
How come? It's counterintuitive, right? So when you have more forest, usually we are expecting the cooler temperature. No?
Yeah. But for Africa and Central South America, it was as we expected.
No, this is the same. When the forest area decrease, then the temperature increase, okay. Interesting. Okay, so you said that the y-axis in a forest area, that is a percentage.
Yes, percentage of the land.
Okay. So then Central, South America, this percentage is pretty high. And then when you go back to Asia, North America, Africa, it's pretty small. Yeah. Okay. Yeah, looks like yeah, you mainly focus on whole continent-based analysis, right?
Yes.
No real comparison across a continent. Am I right?
Yeah.
Yeah, I think yeah, you can do some more kind of research. So numbers are somewhat different, right? In Asia, definitely forest area is pretty small, but there is a very clear positive correlation. In some other areas, the forest area is almost doubled compared to Asia, and suddenly the behavior is quite different, right?
Yeah.
So it's not very intuitive. So maybe you need some kind of the interpretation. Maybe you need to study some other the extra maybe factors or science. I don't know. Okay.
Okay.
All right. Okay.